All right. Not coming up. Let's find out. It's like one of you guys have done the assignment. That's good. Looks good for me.
Oh, it's not under the actual stuff.
Yeah, like a week or two ago, I said I'd put a PDF in the content for the week, stating exactly what I want from the assignment. So, that's your.
Thank you.
All right. So, just for clarification, last week, the reason it was not passing is I wasn't giving it proper variable. Oops. Shouldn't work. Oops, I forgot that. If I try to print it, total not fine, but if I return it, oh, so if I, well, anyway. This is not the example I wanted. Well, never mind that. I didn't use return properly again. That's fine. So, today we're going to talk about decision structures. I decided against making it a whole assignment based on decisions, whiles, and loops, stuff like that, since you've kind of already done it, but I do think it merits a proper explanation. So, here's your proper explanation. So, what are some of the decision statements we have? If something, then do something. We have else if. Those are called decision structures or decision statements. So when we're doing that, we have to essentially tell it what it's comparing or what it's doing. So I mean, we've done this before. Let's go through all of them. So let's say, we have greater than, everything there, greater than, less than, equal to, not equal to, then equal before it or after it. After it. So we have greater than or equal to, less than or equal to. So those are all the things we can use to compare stuff. greater than, less than, equal to, well, technically it would be that, 2 equal signs. Not equal to, greater than or equal to, and less than or equal to. So those are our relational operators. You gotta make sure you use the right relation operator. So there we go. So I forgot to put my second time. So whenever you use an or and you have to put the variable again. It doesn't intuitively know what to do. So what is my if statement stating?
If the temperature is lower than 60 or above 75.
Yeah, but that's the other way. Remember the Pac-Man wants to eat them.
Oh, yeah.
So if it's greater than 60, yeah. If it's greater than 60 or less than 75, it's a nice day. And then or, you guys remember or? One of the statements has to be true in order for the statement to be true. So this doesn't really work, does it, using an or? Because it works because we have them both kind of pointing inwards towards each other, but that's not really the operator we're looking for. Really, we want to use an and here because it compares both. We want temperature to be greater than 60 and less than 75. So in order for this statement to be true, both of them has to be true. Because say, you know, the right side was another, you know, definition that you wanted it to be. It has to, if you wanted it to be one or like one or the other, or would work. But if you wanted it to be both, and let's say, and whether equal to there. So this makes a little more sense. Of course, nothing happened. Why did nothing happen? There's fair. I don't think this matters. So something is breaking this. Oh, because temperature is less than 50. So let's make it. That's why we were getting that false positive, because it was less than 75. So let's do 62. There we go. So you see the problem that came up? The temperature was set to 50. It wasn't greater than 60, but it was less than 75. So it hit that or, one of them determined to be true, so it came out as a false positive. So we fixed that by putting in the and then we changed it up a little bit. Does that make sense? So be careful when you're using and or. Make sure you know the difference. There's also exclusive or XOR, which means one or the other has to be true, but not both. If both of them are true, then it's false. So like, let's see. What's a good exclusive or statement? So if you like cats, exclusive or dogs, you're a normal person. But if you like both of them, then you're not. You're a weirdo. Let's just make believe for a second. So if we were to use an exclusive or, if both of them are true, then it's false. You're a weirdo. You like both cats and dogs. What kind of person are you? But if you like one or the other, then you're a normal person. It's kind of a weird example. I understand that, but that's kind of how exclusive or works, and that comes later on. But for now, we're just kind of talking about decisions. So let's move on to if else. So essentially what else does is anything other than the exact specifications we've made. So if we were to put make that raining, oops, I didn't indent it. Because it has to be under this else, 1, 2, 3, 4, there we go. Love Python. What a yucky day this is. So since both of them are not true, the if statement doesn't happen, and it falls onto whatever the else is. Now we can also do elif.
So that one's more specific, right?
Yeah, this one is more specific. It won't check the other things if this one is determined to be true. Elif, say whether equal to there or sunny. Oops, gotta put the colon in there. Let it know that it's a kind of a milquetoast response. So essentially what this is saying, you know, even if it's cold or if it's hot, as long as it's fair or sunny, it's still a pretty good day. You know, if it's like 32 degrees but it's sunny, it's not too bad. It's, you know, assuming it's not terribly windy like it is in Oklahoma. Because even if the sun's shining and it's like 20 degrees, if the wind's blowing, it's like a -2, it still sucks. That's just Oklahoma for you. And you can also use an if statement here, but it's usually a little bit better so you don't get multiple responses. So and it kind of separates the two a little bit better. So let's change it to temperature is
12. It's okay.
Yeah, it's 12 degrees and raining. It's going to be a yucky day. Let's do it, but it's sunny. So it's an okay day. It's fair. It's fine. It's not too bad. As long as you're in the sun, it ain't too bad. You got a black jacket on. Absorb some of them rays. You'll be all right.
12 degrees.
Yeah, 12 degrees. As long as you got that sun on you.
Good hoodie.
This little a black hoodie would be really nice. Kind of soak up that heat a little bit. As long as it's not like sheer and it's windy. But. So that's kind of how that stuff works. For those of you who needed a clarification, because you do use these in that function example I gave you, and I kind of wanted to explain what it is you're doing. So let's talk about loop structures. Can anyone name the loops? What's that?
It's about 30.
There you go.
How about
What is it?
why?
While? You didn't say why, did you? Yeah, you said while. While is a loop structure. That's correct. What's another one? For, yeah. Those are your two basic ones. I think those are the only two in Python. For loop. In other programming languages, there's a for each. I think I'm sure Python has its own. But we don't really talk about sentinels. Let's talk about loops. Let's talk about the while loop. So the big problem with loops is that if you create an infinite loop, you're going to break your computer, break your program, break the server that you're working on. Maybe not, but it's not a good thing to do. If you have a server with a set amount of data or a set amount of CPU it's allotting you, and you create a while loop that goes on forever, it's going to cause some problems. You'll have to kill it because it won't kill itself because it'll just go forever. So I caution you whenever you use them to make sure you have an explicit break statement or an explicit way for it to end. So let's do.
So if I don't, this computer will explode.
No, these shouldn't because it's a small program. But if it's a very large program, you can definitely freeze it, and you'll have to either Alt F4 or Control Alt Delete. So let's do x is equal to 0. Well, x is less than 10. I think you have to put them in parentheses whenever you do loops. I know you do in PHP, so let's just pretend we have to do it in Python. I think that's how you do it in Python. Most other languages, it's just like plus plus, but I think that's how you do it.
You don't space them.
What's that?
You don't space them.
You don't have to. If you do space them, just do it every time. Make it consistent. We'll just assume that's right. It'll bark at me if it's wrong. Let's down one. Print. So what do you think this is gonna do? There's probably a way to, so is it star slash star? That's every other language except for Python. Oh, is it I forget what it was. There's a way to do like multiple lines as a comment, but I forgot what Python's is. So what do you think this is gonna do? Why is that? But it's less than 10, right? So it's going to print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because 10 is not less than 10, is why it doesn't do that. So we gave it a defined parameter. We use this is called a counter. So each iteration of this while loop, the counter increases the value of x. This is a good way to make sure that you don't break something. Not always useful, but I actually use it at work. Whenever I'm checking through multiple lines of stuff, like, find LTM profile, and once found, increase the line that I'm looking at by 1, and then search that line for a specific string. If that doesn't work, do it again. Add counter 1, your value equals present location plus 1. Does this line have it? Does this line have it? Does this line have it? In my while loop, I always say, while line does not equal LTM profile. So as soon as I hit the next LTM profile, it breaks. But if I'm at the very last LTM profile, it's going to head to the end of the array and not find another one. So I usually give it like and counter is less than 10. So whenever I hit that last one, it doesn't forever break itself. So I use a counter at work as a kind of a fail-safe.
So not like restart the program. Or,
Well, I'd have to kill my search,
uh,
which involves going down into the root user of Unix, and I'm not supposed to do that. But I have in a few times by accident because I broke something. So this is just a basic counter in a while loop.
It does it for negative numbers too. I just did negative 300 and it was awesome.
I got tried.
Yeah, it'll keep doing it, but just make sure you don't don't break it.
Try that.
Make x equal negative 300, not that, because it'll break it. Well, I don't think it'd break itself. Well, yeah, well no, it wouldn't, because it just wouldn't work. So what happens when we put a loop inside of a loop, which I do every day? I have a for each loop, and then I have a while loop inside of it. What is that called? Anybody know? This is called a nested loop. It's a loop within a loop. Nested. So whenever your professor says, we're going to use a nested loop, you know what that is. So let's do a nested loop within this. So So what is this going to do?
Anything between 0 and 19 is going to be the y.
Is it?
This is y. Yeah.
How many times is it going to do it?
18. 19.
10 times?
Yeah, 10 times because it starts at 0. So it's going to do 1 and then 0 through 19, and then 2, 0 through 19, 3, 0 through 19, because essentially what it's doing, it's going to do the while, and then it's going to run this portion of it, then it's going to run this portion of it, because it just takes it line by line. Remember that. So while x is less than 10, print x, which is going to be 0, and then it's going to add to it, and then it's going to hit this for loop.
This is y.
Yeah. So when we do it, see x is 9, and it does that. So that's what it does. Does everyone understand why it did that?
No, honestly.
It's hard to explain, but in my mind it's kind of like a graph. Like if 9 is this, then y is this, and then it just keeps going.
Right. Because essentially what this statement says is, for y in range 0 to 19, print this. And this part happens, this part keeps happening until this part breaks. Then once this part breaks, it goes back to the while. And then while x is, so it's 0, is x less than 10, is 0 less than 10? Yes, print 0, and then add 1 to it. So now x is 1, and then for y in range 0 to 19, print that. And it's going to keep doing this part until it gets to 18. And then it's going to, this part ends, and it's like, okay, well, what do I do now? Well, I'm still within a while loop, so let's go back to the while loop. Does that make sense?
Numbers are crazy.
So,
I like the way you said about the graph though. That it's like you have a different number of points that you can. Yeah, that's what.
so remember, it takes it line by line. So whenever you're doing this in your head, remember, whenever you put this while in, until this while is met, it's gonna keep doing it. Whatever is in here, whatever is inside the while loop, as long as this remains true, it's gonna keep doing it. Now we can say,
I have a question.
So.
If you use like decimals and stuff, would you have to import math, or would it do it?
You can just make it a float. I'll need to put this before this. That's going to happen inside the for loop. Okay. So what have I done here?
It'll break if x equals 7.
Right. And I put it outside the for loop. Notice my spacing indicates that this is outside of this for loop. The first way I had it, wouldn't really do much until it went through that, and then on the 7th time. So it would still do that, even if x was 7.
Okay, so since you put x equals 7, it's going to break once it hits 7.
Yeah. So now what happens, whenever this while loop, whenever the x hits 7, it's going to do this the last time, and then it's going to find it. It's equal to 7. Let's break it. So it's not going to do 8 and 9. Does that make sense?
Mm-hmm. Yeah, it's about 6.
I think. Because it's outside the for loop. So it should. Where's the last? Yep. So it doesn't even.
Go to 7.
It doesn't even. Yeah, it doesn't even perform. So essentially, what it's doing, it's checking before it even really hits that for loop. So. And this seems really menial and doesn't really mean anything, but whenever you start actually doing stuff like this, it's really important to know exactly what it's going to do, because, say you're trying to email, 6 people at a time, because that's all your email server can handle, but, you F up your for loop or F up something, and it does it a 7th time because you miscalculated and you break your email server, or, say it's like you can do 10,000 at a time, but you accidentally do 10,001 and it essentially doesn't work. And so you run this script all night thinking, okay, we're going to email all of our customers. And the next morning on the very first line, it says, oh, 10,001, can't do it, shutting down. And then you have some explaining to do.
We had a question.
What's up?
I'm doing what you did, but for some reason when I run the program, it's just constant zeros.
So it's not hitting the plus. So you must have hit that. Intelliger's invention is probably correct.
Yeah, it's crazy.
It's actually
I
points.
had this, it was all kind of like gibberish. Then I had this weird data.
The if is inside.
Just like
Yeah.
The if is inside the for loop.
Pretty smart guy.
So you take that if out. Then move the break back as well.
Get rid of this. Oh yeah.
Hey, you tried that 2K game yet?
Not yet, dude. Not yet.
Yeah,
I
because
don't think I don't know.
yeah, because essentially what it was doing, it was
Oh, no,
doing
I
that,
didn't.
and then it was setting. You're adding it, then you're setting it back to 0.
It's better.
Oh.
It's better, so you just kept making it 0.
Patch a lot or
I noticed they have
okay.
Any questions on this stuff? It's kind of just a basic overview I wanted to give you guys. So I'll bring up what he just did. So he had this essentially written twice, and then he had it down here, x equals 0. So pretty much all the work he was doing, every time it added, x, 0 plus 1 is 1, set x to 0. So then it'd go back to here and print 0 and print 0 and print 0. So he made an infinite loop.
He survived it.
Yeah. Like I said, it's not a big program, so
8.5
but so that's how easy it is to jack something up. Super easy. So whenever you guys are scripting, pay close attention, read it line by line, make sure you don't have lines that undo previous lines like this. What this one right here does. This one right here essentially undoes this line.
Are loops like really common?
Yes,
Okay.
extremely common. You will use loops very frequently, especially when you're searching through stuff. Because it's like essentially if you're looking for something, so while so like say you're searching an entire file for your name. So say like you get the graduation letter and it has everybody's name on there, but for some stupid reason they put it in alphabetical order. And say you go to like Ohio State and there's 10,000 graduates this year. You're like, did they put me in there? I don't know, because this is a giant load of crap. So essentially what you can do is you can take each line and say, while not end of line, so like the very last line. So while there's a line, search for Lee McWaters. And it'll go through every single line looking for your name. And then if found, print, there I am, line whatever, 878. And then if you're not found, whenever it hits if end of line, then print, you're not in this, they jacked something up, and you need to go yell at the graduation people. Parentheses, what's up, dog? What's up? Yeah. So
you have failed.
yeah, it's like, hey guys, I'm not in this, and also it's not in alphabetical order. What's wrong with you guys? Clearly, you didn't take Python with Professor McWaters. So I use while loops, or I use for each loops in every single one of my programs. Essentially, what for each does in PHP is it takes for each line. So I have like a huge array, and then for each line in the array, do something. So.
Okay, so is it like are loops just faster for this or?
Yeah, it's a more refined it's a more refined for loop. So, any questions? That's all I wanted to talk about today. You guys can go.